Unfortunately, the electrical instrumentation will be often installed in places where an explosive atmosphere can be created, is the example of gas plants, refineries, or flour silos. In order to have an explosion, we need the coexistence of three elements: the fuel, the oxygen, and the ignition source. An explosive atmosphere contains both combustible, like gas or dust, and an oxidizer, normally oxygen, at the adequate levels to perform an explosion. In that case, the necessary preventive actions shall be taken to avoid that the instrumentation become the ignition source. Plant areas are classified depending on the possibilities to become an explosive environment. Different standard has been employed, and that makes this task a little bit more complicated. However, industrial practices tend to concur into IAC 60079. Mainly, two systems coexist nowadays in the industry. The first one is the THONS system, which is according to IEC 70079 and NEC 505. It's mainly used in Europe and all worldwide. The system distinguishes three zones. The first one is the Zone 0, which is a place in which an explosive atmosphere in the form of gas or vapor is present continuously or for long periods of time. The Zone 1 is a place in which an explosive atmosphere in the form of gas or vapor is likely to occur in normal operation and occasionally. The Zone 2 is a place in which an explosive atmosphere in the form of gas or vapor is not likely to occur in normal operation, but if it does occur, it will persist for a short period of time. Opposite to the system, we have the class division system, which is according to NFPA 70 and NEC 500. It's mainly used in America. The system distinguishes between Class 1, which is related to gases, and Class 2, which is related to combustible dust. We have the Division 1, which is a place where there is high probability of an explosive atmosphere in normal operation. This can be part of the time or up all the time. It's equivalent to Zone 0. The Division 2 is a place where there is a low probability of an explosive atmosphere being present during normal operation. It would be equivalent to Zone 1 and Zone 2. Showing an example of the area classification, we have the following one. Here we have Zone 0 inside the vessel, where the flammable mixture is present continuously. We will see a Zone 2 in the nozzles and the connection points, where a flammable mixture is likely to occur. Finally, we have a Zone 2, where the flammable mixture is unlikely to occur, and if it occurs, it will be present only for a limited period of time. The hazard of the area will depend also on the explosiveness of the present combustible. The areas need to be classified including this parameter. Again, we have two systems, the one used in Europe and the one used in America. The one used in Europe distinguishes between the following zones: Group 2A for atmosphere containing propane or similar gases, Group 2B for atmospheres containing ethylene or similar gases, Group 2C for atmospheres containing ethylene or gases similar, and Group 1 for atmospheres containing methane. The class division system, the one used in America, distinguishes between Group A for atmospheres containing acetylene or similar gases, Group B for atmospheres containing hydrogen or similar gases, Group C for atmospheres containing ethylene or similar gases, and Group D for atmospheres containing propane or gases of the equivalent hazard. There are different methods to protect the instrumentation located in a hazardous area. Let's start for the instrumentation located in Zone 0. In this case, the presence of an explosive atmosphere is continuous. The first way to protect the instrument will be the intrinsically safe. This method is known as EXI. In this case, the energy present in the device is limited from external sources by IS barriers located at the source. Additionally, the device cannot accumulate enough energy to create a spark. Since this protection is dependent on the interconnections, the field equipment certification is not enough to guarantee intrinsically safe protection. Note that passive devices do not need certification if they are connected through appropriate IS barriers, is the case of the switches. Only the equipment certified as EXIA is suitable for Zone 0. Equipment certified as EXIB is only suitable for Zones 1 and 2. Other method to protect is the encapsulated devices. In this case, the electronic components are isolated from the potential explosive atmosphere by a sealed containment made of thermoplastic, resin, or elastomer. This method is used for small electronic components like switches or solenoid valves. Only equipment certified as EXMA is suitable for Zone 0. Equipment certified as EXMB is only suitable for Zones 1 and 2. All the methods employed in Zone 0 can be used in Zone 1 or 2. Additionally, two independent methods suitable for Zone 1 can be used in Zone 0. Let's continue with the protection methods suitable for Zone 1 and Zone 2. The first one is the flame-proof, which is denoted by EXD. In this case, a rush box contains the electronic inside. The containing box is not hermetic, and in case of internal explosion, the produced gas are released to the exterior at low temperature through small leakage points. This method is suitable for Zone 2 or Zone 1 and is used from small transmitter to medium-sized panels. Note that sometimes the EXD devices are called explosion-proof incorrectly. The next method, the increased safe device, is noted as EXE. In this case, the sparks and high temperatures are prevented by means of the use of specially designed elements. It is suitable for Zone 1 and Zone 2. Typically, this protection is used in interconnection boxes that do not contain elements that generate sparks in normal operation. The next method is the purge, also noted as EXP. The internal atmosphere in a panel is pressurized with a safe gas to a pressure higher than the exterior pressure. This method can be static or can consist in a continuous safe gas purge that renews the gas in the compartment. This method is suitable for Zone 1 and Zone 2 and is used in medium to big size panels. Finally, we have the powder filling, also noted as EXQ. In this case, the electronic components are isolated from the potential explosive atmosphere by a sealed containment filled of quartz powder. This method is suitable for Zone 1 and Zone 2. In this slide, we have different examples of marking according to the different standards. In all the cases, the device is exactly the same, a flame-proof device suitable for installation in Zone 2 in presence of ethylene. Note that the characters into brackets do not certify the equipment itself and are only related to its outputs.